Okay, so I will start. So good morning, everyone, and welcome to today's webinar, the blockchain traceability and tool and of the Prime project. So my name is Julia Gomez, project manager at Invenium Group, and I will be moderating today's session. First of all, thank you very much for joining us. We are pleased to have you here for this webinar, where we will be presenting one of the digital tools developed within the Prime project, the blockchain and the traceability tool, and its application to the composting value chain in Living Lab 1, that is located in Lleida, in Spain. So first of all, I will introduce super brief Prime project, just in one sentence, because later on Silvia will be explaining in more detail. So Prime Project is a European funded project that brings together partners across Europe to accelerate the transition towards a more circular and sustainable bioeconomy. And one of our activities was to develop this blockchain and traceability tool that we will be explaining in more detail later. So today we will focus on a practical question. How can digital traceability and blockchain certification help create transparency, provable evidence, and trust across circular bioeconomy value chains? But before we begin going deeper into that question, just I will explain the structure of the, one sec, because I need to move. So the structure of this webinar, it will be different presentations of the partners, followed by the Q&A session that it will be at the end. So the idea is, if you have questions during that meeting, you can write on the chat, and also there is like a Q&A box. And then at the end of the session, we will be answering your questions. But before starting, let me briefly introduce our persons that will be present today. We will start with an overview of the Prime project, as I said, presented by Silvia. She is a PhD student at Ruhr University of Bochum in Germany, and they are the Prime project coordinators. Then it will be me presenting and introducing why traceability and blockchain are relevant in the context of circular bioeconomy. After Jordi Malgosa, that is an agriculture engineering at Alcaraz Bioproductors, that is our Living Lab 1, will be sharing the plant perspective and explaining why traceability matters from the point of the Living Lab. And then we will move to the more technical part of the session with Josep Papiot, also agriculture engineer at Akis International, who will present the blockchain and traceability tool developed for the plan. So also Josep will be showing the dashboard administrator, and later share the main lessons from the development of the tool. And finally, as I said, it will be this Q&A session. So then we can move to the project overview. So now it's my pleasure to give the floor to Silvia.
Yes, thank you so much, Julia. So hello, good morning. I will introduce you to the Prime project, some information in a nutshell about this project. So the Prime stands for redesigning the primary sector for maximizing bioeconomy development, and some very brief information. So this project has duration 36 months, ending this year. However, the results are not ending this year. They will last longer because the impact lasts longer. Project brings together certain partners from 8 countries, and this is supported by approximately 4 million euros of funding. And the project actually addresses a major challenge in Europe, that even though the large amounts of biological resources are generated every year, exactly the primary producers, such as farmers, foresters, fishermen, they often capture only a small share of the value that is created from these resources. And Prime actually aims to change this by helping primary producers become active participants in bioeconomy value chains, rather than just being simple like suppliers of this raw material. And this project brings together not just universities, but also research centers, technology providers, innovation organizations, industry partners, to create actually practical solutions that can be replicated across Europe. And as shown on the map, Prime implements activities through 5 living labs, and they are located in Spain, Portugal, Italy, Ireland, and Finland. And these living labs, they serve actually as real-world testing environments where these innovative technologies, the business models could be validated, and the collaborative approaches could be tested. So the aim of the project, so what's the main goal of Prime? And the core objective is to create innovative forms of cooperation that integrate primary producers into the new bioeconomic value chains. And the Prime addresses also this challenge through a multi-actor approach, so it brings together these stakeholders that maybe usually would not talk to each other together, and also not only them, but also foresters, fishers, so the primary producers, but also researchers, companies, also investors, also policymakers, and the end users. The project actually also develops the circular business models in the bioeconomy, and they are actually designed to generate economic, also environmental value and social value at the same time. So the Prime does this through the 5 core objectives. So the first one is to establish the necessary framework conditions by building knowledge about economic value chains. Then it is to develop new circular business models in bioeconomy, so they are not only bioeconomy based but also circular. Then another objective is to create the collaborative ecosystems that is done also through workshops, digital tools, or shared agendas. Then another objective is to demonstrate and validate technologies and business models in the 5 living labs. Then the objective is also to focus on lessons learned and the policy recommendations, and that the best practices could be replicated across Europe. And we have also the Prime ecosystem, because it's not only about technologies, but it is about also the actors. And we recognize that the value is across corporations, across more sectors, that as I said already, would not maybe usually talk together, but Prime brings them together. And we support the co-creation of new business models, new governance models. Then the project provides access to specialized technologies and technical expertise. It develops, of course, sustainable business models and circular business models with the view of long-term viability. And we also improve the public awareness and acceptance of, for example, using these waste streams, that they are basically valuable resources. So now let's look at how Prime actually achieved these goals in practice. So the project demonstrates these innovative solutions, as I said, in 5 living labs, and each living lab uses different biomass resource based on their sector and based on the resources they have. So here you can see the 5 living labs. So the first one, Alcaraz, they are in Spain, and they use livestock waste and agricultural residues to produce biofertilizers, biomethane, etc. Then we have in Portugal, Portuguese living lab. They transform agricultural residues such as husk into functional silica nanoparticles. Then we have the Ligurian Italian living lab. They focus on fishery waste, and they make also fertilizers or bioplastics from that. Then we have the Irish living lab, so they use the dairy byproducts and forestry biomass to produce the acid, lactic acid. And then we have the Finnish living lab, so located in Finland, and they actually apply plant cell culture technologies to convert agri-food waste, side streams or waste, into cosmetic applications and other applications. And the Prime results, so to conclude, we can go to the next slide. So let me highlight some expected outcomes of the project. So the results are intangible because we provide open access business model navigator that actually helps stakeholders to design and implement the circular business models in the bioeconomy. Then we create new value chains. Then we actually provide a digital toolbox that is actually like set of methodologies, guidelines, best practices, and practical resources for different stakeholder groups. And we also like primed fosters collaborations through shared agendas, which actually fostered stronger engagement between the primary producers and other actors. And last but not least, the project creates, of course, the economic opportunities in like rural areas. And they are also, of course, economically viable. So the economic opportunities there are then strengthened. Yeah, so this was something about the project in a nutshell. And I would like to give word to Julia further. Thank you.
Thanks, Sylvia, for that brief explanation of Prime Project. So now we will continue. It's my turn. I will be introducing super briefly why traceability and blockchain it is important in bioeconomy. So basically, in the circular bioeconomy, materials often move through different actors, so location and transformation processes. So this makes essential to have reliable information from the origin to the end of the process. So we need information on how they are perceived, which quality controls are applied, and the evidence supports each step. So this is actually one of the challenge of Prime project and this kind of the results. So we focus the traceability in the composting value chain that now in a bit Jordi will explain in more detail. But as I said, circular bioeconomy value chains are based on the transformation of the biomass and agriculture byproducts and other organic materials into the new products with added value. So these processes are highly relevant for improving resource efficiency, reducing waste, and supporting more sustainable producing models. But as I said, so this specific information also is like lost on the process. So we need something to try to organize this information and have like clear and trust information. So because now, for example, this information is fragmented in all these steps in a lot of Excel files involving a lot of different actors. So that's why traceability is important. Basically, traceability helps to prove the origin of the materials, as I said, monitor these transformation processes, support quality control, facilitate certification and audits, build trust among these stakeholders, and increase transparency. But Prime goes one step further by combining traceability with the blockchain certification that also Josep will explain in a bit more detailed information about this blockchain certification. So basically, it is important to clarify that the blockchain is not used here as a replacement for traceability system. So it's like a combination of both. So I think I don't want to explain a bit more because then, as I said, Jordi and Josep will give you more examples and the practical results that we did during the project. So now it's the moment for Jordi Malgosa to explain from the side of the Living Lab in first person how they apply this traceability in the Living Lab that it's Alcarràs Bioproductors and why this traceability matters for them. So Jordi, the floor is yours.
Thanks, Julia. Good morning, everyone. I will give an explanation of our case, Alcarràs Bioproductors. First of all, I'm going to start with an introduction. It's a cooperative created by more than 150 families from all the area, which they all come from farming ancestors, and they need they urge to have a way to manage the slurry and the manure they generate, because there's not enough surface and not enough field to apply the slurry that you generate. So having this trouble, there's the plant. It all started there, first with the composting plant and afterwards with the biogas plant to give a solution to all the partners and farmers from the area. And basically, we manage more than 250 farms, and we need to be really accurate with the information. We have to make a good traceability, and this obviously with the huge amount of waste we manage daily, there's a need to make it more efficient than it might be. You can move next, Julia. Yeah, here we can see the composting value chain. First of all, the farm, our transport stuff goes to the farm, and then they have to load all the manure. Afterwards, they have to transport back to the Alcaraz bioproductors. We need to receive, to analyze it, to see if it's viable, and it may be a good product for the future compost that will be processed. Afterwards, we try to mount the pile, and finally, not finally, but simultaneously, we make analytics laboratory, and this all needs to go in the traceability. So that's a bit messy if you don't have a tool that enables to have all this data in the same file or in the same IP. That's why one of the solutions, as you may see in the next slide, here, for example, is why we had the chance that offered Akis, the blockchain, which would enable us to avoid using Excel files, to make a big effort and invest a lot of time in traceability in a way that it's much more secure, firstly for the farmers, second for the staff, the Alcaraz bioproduct staff, and then it's easier to find all the information, not only the analytics, but also all the information for the consumer, the final consumer. And that's what we want to make it easier for them, that they can find till the beginning the manure that is decomposed, and the consumer can see the whole process that has been taken till we get the pile composted. And then we have 4 ideas that obviously is one trusted traceability flow from the material intake to final output. That's essential, and it's part of our aim. Then we have, of course, less time spent collecting, checking, and reconciling evidence with the blockchain. Then Josep will give us more detail following. It enables them to be much more efficient, to spend less time collecting data, to make some mistakes that may arise sometimes. Secondly, easier reporting for audits, certification and stakeholder requests, because you have all the information in the platform. You don't need to check all the files. You don't need to join all the information, but because you all have it completely in blockchain area. And finally, a stronger position when clients ask for transparent proof of origin, process, or impact, because this is one of the problems we may have today, that if a client wants to know from the origin of the compost, we probably need a lot of time to find the traceability corresponding to that file. Otherwise, if we use Aki's tool, blockchain production, where we store all the information, and then we can see easily with visually the beginning, the whole process that has been taken since the entrance of the raw material, then the client might feel more grateful and give us an added value, of course. Next one. Okay, I've been talking in advance, but this is what I wanted to say. Digital traceability is the main goal. We need to connect the data. It includes, as I've said from the beginning, the identity of the farm, the date, the location, the weight, photos using QR that involves all the information. Then we have the labs as well to analyze all this composting and manure. And blockchain is a really good solution. X has been collaborating with us and installing the system, and it's very verifiable, reliable, and makes it much more easier for us to give an added value to the consumers and to be much more efficient in terms of the inner collaboration. And
Yeah,
finally,
go ahead.
yeah, I just wanted to summarize a bit. The tool combines digital traceability and blockchain to increase transparency, support verification, and build trust in the transformation of agricultural byproducts into value-added products. That's what I've been saying. And Josep will give us more details of blockchain. Thank you very much for your attention.
Thank you, Jordi. Thank you for your explanation. So, Josep, do you want to share maybe your presentation?
Okay.
And then you can continue with the next slide, okay?
Okay, perfect. So
Vale, give me 1 sec. I will stop sharing my. Let's try.
Yeah, I try to share my screen.
Can you? Yeah, perfect.
Yeah, it's okay.
Now we are seeing all of us, so you
Perfect.
have to share the.
Perfect. So if you can see that.
Yeah, perfect. In a presentation mode, and then you can continue with the other one, Josep. Yeah, so not the other one.
So thank you for this webinar. I will explain a little bit the tool that we developed with Gradisoft. It's a company that make our ideas reality. So I will share that. Okay. Yeah. So why traceability? This one, it's already commented by Jordi. Yeah. So why we need a traceability system, a solid traceability system in this compost process. Yeah, we have a lot of farmers that they are producing manures. This manure it's going to the plant, and there they aggregate a lot of farms in trenches, and they get these trenches to compost in some way. So we need to understand this process to know which phases are relevant to acquire and after that certify. So traceability system collects and connects this key data, origin of the manure, movements that they are going with trucks, transformation process, and finally this amount of transformation process that gets into one lot. And blockchain, what does or what acts in this chain? Blockchain only certifies these key points, that it's farm collection, and after that compost process ending, and lot creation. So if we go ahead, this traceability system allows us to reconstruct the full history of the material. In every time we can know every part of that compost, where we came from, and how was ongoing during the whole process. When and where was it received, how was transformed, which batch was created, and after that evidence of the quality based on related on laboratory analysis. without traceability, and it's difficult to have a certification or audition depending on a lot of fragmented records. So we try to get all this stuff in only one tool. Traceability system collect data and organize that data that it's easy to see, to show, and to work. And blockchain certifies these key events by creating a hash that it's a proof that this data cannot be modified afterwards. So what is this? This tool is certifying that the traceability can be changed after the process it's already collected. So we use blockchain in 3 points. The first one is the end of farm collection. So it is proof that this farm entered that quantity, that amount of manure, so that can't be moved or can't be changed in the future. When a composting trench is completed, so we know that this composted process is saved and it can be modified afterwards. And after that, the last blockchain certification is the creation and the closure of the final compost lot, and it's added with a laboratory analysis. So the client that it's buying this compost can know that this lot it's already that, and it can't modify anything. To understand what are the phases of the process, it's that it's critical, because you have to know perfectly what are the phases or the whole process to have a record data of each part. So we have the farms that they are the origin of the materials. After that, we have the carrier that they are the ones that pick up and deliver the materials. In the plant reception, we have the weight and the evidence of that entrance to the plant, to the composting plant. After that, we put in the composting process. We start the composting process in the trench or the piles. So there we start recording all the composting process, and after that we get the final lot with all the trenches that we are mixing in the same lot. And finally, the end user can consult the whole information, so it from the end user can know exactly the origin of that compost, where it comes from. What evidence we capture? We get exact information of each farm. Each farm gets a QR code with all the information that it's the name, the location, geolocation. Automatically, we get the date and the time, so we know exactly which days are collecting the manure. The weight it's recorded, so we have exactly which amount of manure it's collected every day, and we have a photographic evidence of that you can modify this data. After that, in the plant, we collect the process status of the composting process, the composition of each trench, which amount of every slurry or compost or of manure or vegetables it's in each trench. And after that, we get also we can add the lab results of each compost pile. The combination of these elements in all the whole chain reduces a lot of manual entering data, so it is less possibilities to have errors. The platform architecture, this tool that I commented that we developed also with Gradisoft, combines a mobile app and a dashboard web. So the mobile app is the one most useful for the plant operator and the transporter, and it's the base to enter the data to the traceability tool. And the dashboard web is the one that can control each phase of the process with the computer. Blockchain certification is added in these 3 points that I commented before. And we have 4 role-based use access. That one is the carrier, the one it's that it's pick up the manure from the farms and deliver to the plant. The second one is the plant operator, that it's the one who takes the process of the composting process. The producer or farmer, he can in real time knows how is going their manure collection. And finally, the administrator that can have a general overview of the whole process. What have to do each role? The carrier needs to scan QR codes when it's in the farms or where it's in the plant. So this QR gets the reliability that they are in the farm or in the plant, because the QR is located in the farm or it's located in the plant. So it's an evidence that they are there and not in another place. Plant operator manage reception, piles, trenches, turns, that there are movements in the compost process, batches and samples. The producer can check with how is going the withdrawals of his farm, and system administration supervise all the whole process. Where we use blockchain to certify, the first point is origin plus delivery. We certify when we finish whole delivery, we certify it in blockchain. So it's no further modifiable the amount of manure that came from that farm in that event. The second point that we certify to blockchain is when we end the composting process. So we certify that this pile or this trench is empty and how the process has been done. And the third point that we certify is the final lot creation and the final batch. That it's the when we collect different composting trenches in one lot. And also in this point, we add an analysis, a laboratory analysis that the client can look. If we have a look to the mobile app that it's already done, we will start with the transport operator. So it's really simple for them to use, so they don't need to add nearly any manual data. So for them it's really easy to use. When they arrive to a farm, just they need to initiate a new pickup or continue an active pickup if they need to do more than one trip. When they initiate a new pickup, they need to scan one QR code that is located in the farm, and after that they get all the information of this farm, the name of the farm, the official register of the farm, the location, and the data, the day of and the hour. He only needs to select which kind of material is collecting, and after that, when he arrives to the plant, the composting plant, he needs to scan the QR code that is located near the scale in the plant, and just introduce the weight of the truck. So this is an evidence of the amount of manure that they carry. For the moment, this entry of the weight it's manual, but to confirm that it's not further manipulable, it's needed to take a photo of the scale. So that's the way that we can certify that this is a real weight and not an artificial one. When they finish all the pickups, they can just complete, click this and it's completed the pickup of that farm, and this event it's saved to blockchain automatically. So we have all the collection process automatically saved in blockchain, so it can be further modified. The plant operator also works as with an app, with an application, and it's also really easy to use. So each trench that it's used for the compost process, it's named with a QR code also. So the plant operator needs to scan a QR code of the trench, and the app shows all the information of that trench. When they start completing one trench, they need to put the percentage of each raw material that they are adding to the compost process. For example, manure, slurry, vegetable portion, or whatever they put, and it saves that. When the trench is completed, they start the process of composting. So this trench is saved as composting in process. So every time that they need to change this pile or do some different actions to that trench, they can add different actions on that. If they need to move from one trench to another, that sometimes is needed to complete the fermentation process, they only need to scan another QR code of one empty trench and just put in the application that they are moving from trench 1 to trench 2, for example, or from trench 2 to 3, anyway. So the trench is receiving material from one to other. All these changes during the composting process are being recorded. When all the process is ended, we just confirm that we have ended the process, and after that, here we have more images that we are how it's recording the data that moves from one trench to the other trench, and every time that we are moving, it is saving the data and the time that we are trying to do that changes. Finally, when the compost process is ended, we can just end the trench process, and automatically this trench goes to ended trench process. So it's saved as a ended process. When we end that process, automatically we generate the second hash. So it is the proof that we can certify that, yeah, and we can't move or change data in the future. And all this information, it's saved and recorded. The farmer overview, it's more simple. He can't interact with the process, but he can see in real time how it's going, the pickup from his farms. So he can look for the total amount of manure that they have been collecting in their own farms, and the days that, and the trips that they need to collect all the manure. And if we have a look to the dashboard, we have two options in the dashboard. That is the client portal. That this one, it's for the clients that can have the trust that we are doing the things correctly, so they can have a look of the compost lot that have been created after unifying trenches. So in each lot, he can view all the lot details. So they have all the information and the reports of the analysis attached to each lot. Okay, here we have some examples. So this is what the end user can see. He can have a look of every lot, and also when it's ended and the lab analysis it's uploaded, we have this blockchain hash that they can verify that all the data that it's recorded, it's unmodifiable. If we go to the administration panel, we have a quick overview. Sorry, of this. We have a quick a general overview of all the process in the plant. That we have the pickups that they are ongoing in real time. We have another overview of active trenches that they are in the composting process. We have the information of the ended lots that we have already there to sell, and we have an analysis of how many labs results are pending for that. We also added an NPK saved that is an indicator of how many nitrogen, phosphorus, and potassium we are recycling and for the process. If we go more in detail in the visualization, here we have all the information that it's really useful for Alcaraz and all the ones that they are working in bioeconomy chains, that they have all the information there. We can serve by all the lots, only the ones in progress or the ones that they are already ended. If we go there, for example, we have the whole information of the process. So we have the product piles that were in that lot. We have the blockchain hash that it's in that that certifies that it's all the data there. And we have all the information related to the composting process, the day that we started, the times that we send it to post-maduration, the turnings that we have already done in post-maduration, the day that we finalize that piles. And if we go to withdrawals, we get the complete information of the days that we are collecting the manure. We also have the hash that certifies that it's real. And if we put we can get the information exactly of the location, the day, the time that this manure was collected. So for each final lot, we can get all the information till the first day that we start collecting this manure. Okay. And finally, we have the lab results that we can verify that we get certification. And here, if we can view, for example, the PDF that we attach with each lot. Okay. So if we continue on that, the dashboard monitoring and reporting is a centralized view of the chain status. We have all the whole information there. We have the indicator of the active collections, active processes that we have right now. We have all the historical data also there. And we have evidence and really hard traceability system on that. We can get this information for audits, for certifications, and for stakeholder requests. So it's really easy to have this information if we have some request on that. And also for the management, it's really easy to authorize new users, have permissions to have a look on the information and the process tracking. What are the benefits for the stakeholders? For the producers, it's really easy. They can know in real time the quantity that they have been collecting on their farms, and so they know which quantity of manure they are producing. For the transporter, it's really easy to work that tool, that they only need to scan 2 times a QR code and just enter the weight of each load. For the plant operator, it's really useful because it's a traceable management of everything. So for them, it's really easy to know where they have putting every part of the process. For auditors, they have a white screen that they have all the information there, so they don't need to navigate in Excel files or just manual data input. So for them, it's really easy to get all the information that they can ask for the audition. And for authorities, it's a strong basis for relying that this circular bioeconomy it's working, no? Because it's really easy to know the origin of the primary products that we need. And for Prime project, I think that it's a good tool because it's really replicable. The concept itself, it's useful for every bioeconomy based value chain. So I think it's really important that if we understand the whole value chain, how it works, this tool can be adapted for a specific value chain, for every specific value chain. So what I was saying, the same architecture can be reused when the material in some different materials, actors and control points change. We only need to understand, to have a good understanding of the value chain. So we need to understand the quality, the quantity, what are our sources or inputs, what is the transformation process, the transformation, the records that we need, and which indicators can be easily certified, and these indicators can be certified to blockchain. The outputs, so we need to know the quality, the quantity that the outputs will be, and after that the verification that the certified events can be trusted. So this tool, we think that can be used in replicable to compost biomass, which every agricultural waste, biomaterials, and whatever another circular supply chains without any problems. So what we learn in that process, the principal thing is that traceability must follow the real operation flow. So we need to understand perfectly what is the real operational flow to can get the important data of each step. So we need to understand the process, the actors, the final product before defining what critical points should be certified in blockchain. The second is that blockchain should be selective. It adds more value when we apply a few critical points that certifying everything. So we need to focus on which parts of the process are the ones that they are important to certify. The tool must be adapted to each case. So every process is different. Each value chain has different users. So we need to understand each value chain, each case, to adapt this tool. But the concept is the one that it's the one that it's work. And the usability and interoperability is what makes the system robust, that we need simple data enter QR scans, wedge photos, Rappler results. So we need to have a really easy ways to enter data to the process. So that makes the system more robust. So blockchain traceability is viable and valuable when it's implemented gradually. So focus on critical points fully aligned with the operational reality of the value chain. So we need to adapt each traceability system, each certification to blockchain to the reality of each value chain. We challenge it different limitations during the process. That now we have a prototype. It's already working, but it needs a a maturation process before it will be fully usable. So system integrations require further development because, as Jordi said, they have a lot of farmers, a lot of quantity of manure every day moving. So we need to have a really huge database and programs that allows us to manage this huge quantity of information. Then we have some limitation with connection with the scales, thermometer, sensor, laboratory systems that require that for the moment we need to add some additional technical resources. The manual inputs are useful for the process, but it will be important to get this process automatic to improve reliability and reduce some errors during the manual entrance of the data, and also strength traceability. The tool must remain flexible because we have some changes in the process sometimes, and if we don't have a tool that is flexible, it will be obsolete in just a few years. So it has to be some kind of flexibility in the tool. And the real operations might include exceptions because in real world, not 2 + 2 never is 4. So we need to have some points to add some exceptions that should be managed without redesigning the whole application. The next step is that we need to consolidate the database and data model. We need to finalize the information to be collected because we had some changes talking with Alcaraz, so we need to validate and link other collections, deliveries, trenches, how to add batches and laboratory results more easily or automatically. We need to test the tool with real operational data, just make a good test to validate the full flow with users from transport to plant and farmer and user roles. It will be great to connect the tool with automatic weighing systems, temperature rockers, and other inputs that now we are entering manually. Improve robustness and scalability. So we need to make that tool robust and ensure the platform can adapt to different value chains while keeping data collection simple, because in the reality, normally each company has more than one value chain, and with the same entrance or the same primary, the same manure, they can get 2 or 3 options of value chain. So we have to think about how we can adapt this to more than one value chain. And finally, the conclusions. Traceability transforms data into trust, recording origin, movement, transformation, and creates a transparent and verifiable value chain. Blockchain adds credibility, certifying key events, provides tamper-resistant evidence for audits, certification, and stakeholder confidence. And digital traceability can be replicated across other bioeconomy value chains, where transparency, quality, and verification are essential. So I will pass the word to Julia.
Thank you, Josep. Thank you for your explanation and showing all the results. So now it's the time to questions and answers. I don't know if any of the participants has any question. So I think there is no questions. So
that one question: how is evolving the blockchain introduction to our plant with the composting plant, how it's evolving, in what step we are.
Yeah, this is a good question. We are right now, yeah, as you know, that we have this I don't know how to say this trial. Maybe we need something more to fully prove there, because it's like a demo. So the thing is that to get this demo real work, we need some more time. Just to add your notes that as we were talking, that we need to get the data of the tracks. So now we have to get it like with a formula. No, we can do it automatically. We need to do some little changes, and also we have to adapt all the databases to get this huge amount of data that you are collecting every day, because maybe you are having 2, 3, 4 tracks every day picking up this manure. So we need to have a solid database to can afford that amount of information.
You have to take into account that we manage 50,000 tons a year, so it's a huge amount.
Yeah, I know.
That must be taken into account.
Yeah, the next step it's just continue developing the tool. I think the concept of the tool it's really good, because we are with Gradisoft, with Robert, we have been a huge effort to arrive farther than that we expect. But now we need to continue on that, to redefine some key points that with you and we were talking the last days. Yeah.
Perfect.
I think maybe we need half a year more on that. On that. Yeah, but yeah, I think that the good point that we get is the concept and the clear way that we have organized the information.
Yeah, because I think for the rest of the things, it was really suitable. The program, the main drawback was the weight, the second weight of the track.
Yeah.
Just to involve it. For the rest, it was perfect and really efficient, as we were talking.
Super. Any other questions?
We have one writing now.
If not, you can send. I will leave. Maybe Josep, you can send through the chat your email.
Yeah.
So if you have any questions, you can contact with Josep directly, or I can leave the Prime project info. Let me check.
Yeah, I have shared my mail.
Yeah, and also if not, you can contact directly to the Prime project. Okay, so I think we can conclude. So thanks a lot for attending and to participate in the webinar.